So one of the questions we have here is what antenna design should we use for the balloon, for the XB radios? Because we're really going to be kind of pushing their range here when we're up at 20 miles or so. So we want really the best antenna design possible. There's very little information about antenna setups that people have used that have worked with these radios, so we don't really have a lot of information to go on. So the most common type of antenna is vertically polarized antenna. So this is, you might have a Yagi antenna, which is directional. You might have your little ground plane antenna on the balloon. This is the payload. This is the balloon. And so this is dotted line is kind of your radiation pattern. So a little bit more gain to the sides. Depending on exactly what type of antenna you have, you can have the gain pattern might look something like this. Not as much directly under, and directly above not as much, less above. So we have kind of two problems. One, we're going to be on the ground and receiving a signal from the balloon some of the time. For the recovery, we might be in the air trying to receive a signal from the balloon. So it's important to us to actually radiate a signal up and down. Another complication with vertical polarization is when you're on the ground, keeping the antenna vertical as with respect to the balloon is actually kind of tricky. When you point the antenna up, you're actually tilting it, so it's not vertical anymore. It's actually, if you're tilting it up, now you're going to actually come off of this vertical axis. The other thing is you don't know if the balloon itself is actually perfectly vertical. So this is another problem. So what we decided to do is use circular polarization. So the idea with circular polarization is we're using right-hand circular polarization. So the polarization is kind of changing, and it makes one full rotation. It goes from, we'll say, vertical here to horizontal, and it does that in a quarter of the frequency, a quarter of the period of the wave. So it makes one whole rotation all the way around in polarization per cycle at, say our transmit frequency 915 megahertz. So the idea is that circular polarization cares less about respect to the ground, so we're really just concerned with making both antennas emit radiation and emit RF in the same circular polarization. So you can have circular right hand and you can have circular left hand. So this antenna that we built, this cloverleaf antenna, has a gain pattern kind of like this. So a lot of gain out to the sides, not so much directly above or directly below. But you have to remember, if we're directly above or directly below, the distance that we're going to have to the balloon will be minimal, since we'll be so close. This is likely if we're, having it come down, or if it's on the ground already, we might be here. And so we want the most gain because there'll be lots of trees and that kind of thing in the way. So we want the most gain here and here. And it does radiate up and down as well. So this is the antenna that will do that. This is a cloverleaf antenna. It kind of has the shape of maybe a propeller. So you can see that it sits flat here on the ground. So the shield on the coax is actually connected to the ground, and that's connected to the ground plane kind of part of the antenna. Whereas the 45s up here are connected to the main conductor on the coax. And so these are cut to specific lengths. They're tilted up at 45-degree angles, and there's 10 degrees approximately between these different segments. So each one of those is 10 degrees. So this is what's going to be on the balloon. It'll be fastened like this, so upside down, I guess, and it will be giving a circular right-hand polarization. We'll then receive the signal with our elliptical antenna, which we have here as well.